Brain health has been very popular in the news lately, and this podcast is for you if you've ever had brain fog, cognitive decline, Alzheimer's, CTE, any of these issues. This is the podcast where we're going to jump into the latest research from Dr. Dale Bredesen, Dr. Daniel Amen, Dave Asprey of the Bulletproof Diet, so many other people, all the minds that are really out there paving the way, blazing a path for new research, new strategies that are actually working to get your brain optimized and working at its highest level. The Brain Builders podcast is just for you. So get a notebook, get a pen, and get ready to open up your mind and get back to the person that you were meant to be. Hello, and welcome to the Brain Builders Podcast. I'm your host, Dr. John DeWitt, and today we're diving back into Dave Asprey's book, Headstrong, the Bulletproof Plan to Activate Untapped Brain Energy to Work Smarter and Think Faster in just 2 weeks. And we left off last time talking about the gaps between the neurons, which are called synapses, and they transmit messages from one cell to another, and they rely on chemical messengers called neurotransmitters, and yep, you guessed it, a lot of mitochondria to fuel the process. Now, this cycle of sending a message from one neuron's axon into a synapse and into another neuron's dendrites is the basis for how your brain functions. It is primarily a chemical and electrical process. When a neuron in your brain is at rest, the inside of it contains a negative charge and the outside has a positive charge. The cell membrane keeps these positive and negative charges separated by selectively allowing ions, which are charged atoms or molecules such as calcium, sodium, chloride, and potassium, to move in and out of the cell. The negatively charged ions inside the cell are not allowed out, while positively charged ions can move freely back and forth across the cell membrane. This balance keeps the cell negatively charged except when it's time for some action. When the neuron wants to send a message to another neuron, its cell membrane allows positively charged ions to flood into the neuron, which changes it from negative to positive and makes it fire, causing an electrical signal to shoot down the axon. After your neuron fires, its membrane goes back to work reestablishing its negative charge by pumping positive ions out of the cell while keeping the negative ones inside. Once the neuron is safely recharged to its negative state, it has the potential to fire again. It's called an action potential, by the way. Interestingly, neurons cannot fire a little bit. Every time one of your neurons fires, it does so at its full potential. It does this to ensure that the signal it's sending doesn't weaken as it travels through the axon and across the synapse, hopefully arriving at the dendrites of another neuron with enough strength to be heard. At least it works that way if your axons are sufficiently protected by a fatty coating called the myelin sheath, which insulates the signal. We'll look at what you can do to generate more myelin in just a bit. And of course, there must be sufficient ATP to power the whole process. Meanwhile, the electrical impulse sent through the neuron's axon stimulates neurotransmitters to flow into the synapse. These neurotransmitters help the listening dendrites of the next neuron receive the message and fire in turn to relay it to the next neuron. This is how your brain communicates the message, through a path of connected neurons, one neuron at a time. Together, many of these neural connections or pathways form vast neural networks. They are the seat of all learning and memory, carrying information from your short-term memory to your brain's structural core, where they are stored as long-term memories. If you have difficulty learning new things, remembering everyday tasks, or recalling memories from the past, the strength and functionality of your neural networks may be to blame. So these networks are not only critical to your ability to learn new things and remember others, they are also critical to your ability to focus. In fact, a McGill University researcher recently discovered a network of neurons in the prefrontal cortex, your human brain, that is responsible for filtering out visual information and other distractions. If this group of neurons isn't performing efficiently, your Labrador brain remains in a constant state of high alert, ready to respond to each piece of unfiltered stimulation as if it were a threat to your very existence. Of course, being distracted by all of those excess stimuli makes it pretty tough to concentrate on getting your job done. Thankfully, there are a lot of things you can do to improve the function of your neurons, including helping to build those protected myelin sheaths that insulate the communication pathways between neurons, creating brand new healthy neurons, or just providing more power to your neurons. And that's where the myelin comes in, because it's called saltatory conduction. Instead of the impulse going all the way down the dendrite, it can jump from one gap between the Schwann cells, or what make up the myelin sheath. In between each of the Schwann cells, it can jump, and it actually skips and is a lot faster to do the conduction of the message. So how your neurons can perform better. As you know, all cells have a membrane made primarily of fat. The myelin is a special, thicker fat layer that is essential for your brain to function. Without it, the signals between neurons would simply be lost. We are born with very little myelin, and the process of producing it, called myelination or myelinogenesis, occurs rapidly during infancy. This is the main reason babies develop so quickly, from adorable little lumps to walking and talking humans. On the opposite end of the spectrum, demyelination, or the loss of myelin along the cell's axons, is responsible for many neurodegenerative diseases such as multiple sclerosis. Researchers have learned a lot about how myelin is created and destroyed by studying patients with MS. While the majority of us are unlikely to develop MS, we can all benefit from this research by looking at the methods doctors are using to help patients with neurodegeneration. It takes a lot more work to restore failed myelin than it does to keep yours strong, but the methodology is the same. A type of brain cell called oligodendroglia, say that 3 times fast, does the work to form your myelin. Throughout adulthood, these cells constantly generate new myelin and replace segments of myelin that break. Just as the electric company maintains power lines to ensure smooth signals across a network, so too do these specialized cells conduct myelin maintenance throughout your neural networks. And your maintenance worker cells rely on a proper balance of hormones, particularly thyroid hormones and progesterone, to do their job well. Earlier, we discussed how thyroid hormones affect mitochondrial function and ATP production. Research shows that thyroid hormones are also crucial for the health and survival of oligodendroglia cells, and therefore for the constant rebuilding of healthy myelin. This is one more reason to stay on top of your thyroid health and get your levels checked once a year or more if you are feeling tired a lot. Researchers have found that the hormone progesterone, which we typically associate with female body chemistry, since it's involved in the regulation of menstrual cycles, signals oligodendroglia to initiate the process of remyelinating neurons. In one study, mice that were treated with progesterone had more oligodendroglia cells that were able to repair more myelin. Progesterone is not limited to the female body. It is also present in males and is actually a prerequisite for sufficient testosterone production. If you have low progesterone as a man, your hair falls out, you get fat, and you grow man boobs. Trust me on that last one, as a former 300-pound obese guy with hormones that were out of whack. A functional medicine practitioner can run a hormone panel to check your progesterone level. Dave Asprey recommends that men and women over 35 get tested if they're having symptoms of low progesterone, such as brain fog. In addition to the right hormones, your oligodendroglia cells also need the right raw materials to rebuild myelin. Remember, myelin is made of fat, specifically saturated fat, cholesterol, omega-3 fatty acids, and a few omega-6 fatty acids. This is one reason that Western medicine's war on cholesterol has been so harmful, and misguided. Cholesterol is essential for cognitive function. Your brain makes up only 2% of your body weight, but contains 25% of your body's cholesterol. Most of that cholesterol is in your myelin, which is 1/5 cholesterol by weight. 1/5 cholesterol. Eating enough fats and the right kinds of fat is crucial to maintaining your myelin and keeping your brain signaling both fast and efficient. Cholesterol deficiency is linked to a decline in cognitive function and memory, especially for anyone following a high carbohydrate, low fat, and low cholesterol diet, also known as the standard American diet, which is truly sad, standard American diet. A study in the European Journal of Internal Medicine showed that a diet deficient in dietary fats and cholesterol and high in carbohydrates could contribute to the development of Alzheimer's disease. On the other hand, eating a diet that's high in the right kind of fats has been shown to increase memory and cognition in healthy patients and even in some patients with signs of neurodegeneration. Dave Asprey recently had the pleasure of interviewing Dr. Terry Walls. Her story shows exactly how important a high-fat diet is for myelin production. In the year 2000, Terry, a practicing physician, was diagnosed with MS. Remember, the primary symptom of this disease is myelin degeneration. Terry sought out the best medical care, underwent chemotherapy, and took all the recommended prescription medications. Yikes. Yet by 2003, Terry's disease had progressed to the point where she had become disabled, and she relied on a wheelchair. Her doctors were very clear with her that once her faculties were lost, they couldn't be regained, and she herself had learned the same thing in medical school. You learn it in medical school does not mean it's true. She, however, assumed that she would simply become increasingly disabled until she was bedridden. Lovely. In 2007, Terry became frustrated with the lack of options she was getting from her doctors and began researching her own disease as well as the brain in general. She learned everything she could about the fat composition of myelin and the exact nutrients that the oligodendroglial cells need to maintain healthy myelin. Terry put together a food plan for herself that included lots of healthy, saturated omega-3 and omega-6 fats and vegetables and a bunch of other therapies. Within months, she went from being wheelchair-bound to riding a bicycle 18 miles. From a wheelchair to riding a bike, 18 miles. The next year, she completed a trail ride in the Canadian Rockies. Today, she is fully recovered. This woman had MS and was told that she was basically going to die. Now she is fully recovered because of what she taught herself. She got rid of her wheelchair. She can walk easily and even jog. Score 1 for Fats and for Terry, who now uses her protocol to help other patients suffering from neurodegenerative diseases. There is also evidence that the right kind of temporary stress, particularly a diet that mimics the effects of fasting, can improve myelination. In a new study out of the University of Southern California, researchers looked at both mice and humans with multiple sclerosis to study the impact of fasting on neurons. They found that a fasting mimicking diet promoted myelin regeneration. In mice, the diet triggered autophagy, which is killing the bad cells that were causing damage to the myelin in the first place and stimulating the creation of new myelin. All of the mice showed an improvement in symptoms, while 20% reached a fully disease-free state. How does everyone not know about this? Because it's not taught in medical school. That's why. Interestingly, when the fasting mimicking diet was tested on humans, the control group was placed on a high-fat diet. In this case, both groups experienced improvements in their mental health. If a high-fat diet and a fasting mimicking diet can both separately help people with major myelin decline regenerate their myelin, imagine what combining those two techniques can do for your brain. This is exactly what you'll experience on the Headstrong program. There's one more way to improve your body's myelin, though, and it's through an unlikely source, your gut bacteria. Remember the old saying that the way to a man's heart is through his stomach. Well, I say that the way to a man or woman's brain is through his or her gut. Over the past 10 years, we've benefited from exciting breakthroughs in our understanding of the bacteria that live in our intestinal tracts and the many vital roles they play throughout the body. Research has revealed that the gut and the brain communicate with each other constantly. In fact, gut microbes play a significant role in the way the brain functions and even the way it's wired. In a brand new study, researchers analyzed how gut microbes affect gene activity in certain parts of the brain, particularly in the all-important prefrontal cortex. They compared gene expression levels in germ-free mice to those in normal animals and found that approximately 90 genes express themselves differently in the germ-free animals. To their surprise, many of these genes were known to be involved in myelination and were more active in the animal's prefrontal cortex. When the researchers dissected the animal's brains, they saw that the neurons in the prefrontal cortexes of the germ-free mice had thicker myelin sheaths than the normal mice. In other words, there is a direct relationship between the bacteria in your gut and the myelin in your brain's prefrontal cortex, and it appears that some gut bacteria actually inhibit neuron function and therefore your mental abilities. Researchers are still studying exactly what in the microbiome is driving this difference, but the implications of this study are incredibly exciting for a biohacker like Dave Asprey and myself. Perhaps in a few years, we'll know exactly which probiotics we need to take in order to grow new myelin. In the meantime, it's clear that eating a diet that is high in fat keeps your hormones balanced, mimics the effects of fasting, fuels mitochondria, and supports healthy gut bacteria that will hotwire your brain for maximum performance. That wraps it up today. Next time, we're going to talk about building new neurons. And if you would like a copy of Dave Asprey's book, it is in the show notes, as well as a link to the BrainBuilders Masterclass waitlist. Join that, and we will notify you once our next online class is available. I hope you have a wonderful day. Thank you so much for listening.